Hi there, preparing for D487. OA exam can feel overwhelming, but it doesn't have to be. Stick with us, and we're going to help you with it. Our website hosts a full set of questions and answers tailored to the D487 OA exam, and it won't cost you a thing. Look, we get it. OA exams can be tough, and the pressure is real. That's why everything on our site, from exam guides to practice questions, is available to you completely free. In this video, we will cover questions from Secure Software Development Lifecycle, Threat Modeling and Attack Analysis, Software Security versus Network Security, Static and Dynamic Code Analysis, Cost of Security Defects. So, let's get started.
1. A software company is deciding whether to invest in proactive security during development or rely on patching after release. Based on industry research, which factor most strongly justifies embedding security practices into the development process from the beginning rather than addressing flaws after deployment? A. Faster feature delivery timelines. B. Reduced need for developer training. C. Simplified project management workflows. D. Significantly lower remediation costs. Do you know the answer? Correct answer. D. Significantly lower remediation costs. Explanation. Option D is correct because research consistently shows that correcting security flaws during development costs dramatically less than fixing them post-release, with some estimates citing up to 100 times savings. Option A is incorrect because embedding security into development does not primarily accelerate feature delivery timelines. It focuses on reducing risk and downstream costs associated with insecure code. Option B is incorrect because implementing security practices actually increases the need for developer training, not reduces it, since teams must learn secure coding techniques and principles. Option C is incorrect because adding security into the development lifecycle introduces additional complexity to project management rather than simplifying existing workflows or reducing coordination efforts. All right, let's get right into one of the most fundamental ideas in software security: the economics of fixing bugs early versus fixing them late. A software company is weighing whether to bake security into the development process from the start or just patch things after release. Industry research makes the answer pretty clear. Fixing a security flaw during development costs a fraction of what it costs to fix the same flaw after the software is already out in the world. Some estimates put that difference at up to 100 times more expensive post-release. Think about it. Once software is deployed, you're dealing with customer impact, emergency patches, regression testing, reputational damage, and lost productivity. The correct answer here is D, significantly lower remediation costs. Option A, faster feature delivery, doesn't hold up because embedding security actually adds steps, not removes them. Option B, reduced need for developer training, is backwards. You need more training, not less, when you're teaching teams secure coding. And option C, simplified project management, misses the mark because adding security into the lifecycle means more coordination, not less. Here's a WGU D487 OA exam tip for you. When you see a question comparing early versus late security investment, the answer almost always points to cost savings. The keyword remediation costs is your signal. Quick recall hook, think early equals cheap. The earlier you catch it, the cheaper the fix. 2. A financial services firm discovers a critical vulnerability in a released product. Development teams working on new features must stop and fix the flaw. Which consequence of post-release vulnerability discovery does this scenario best illustrate from a business operations perspective? A. Disruption of current development cycles. B. Increased network perimeter exposure. C. Loss of static analysis tool effectiveness. D. Reduced effectiveness of quality testing. Can you guess the answer? Correct answer. A. Disruption of current development cycles. Explanation. Option A is correct because pulling developers off current projects to fix flaws in released products directly disrupts active development cycles, causing delays in new product timelines and resource reallocation. Option B is incorrect because the scenario describes an internal development disruption caused by a product flaw, not an increase in network perimeter exposure or boundary-level security concerns. Option C is incorrect because the effectiveness of static analysis tools is unrelated to the business impact of reallocating developer resources from current projects to fix previously released software. Option D is incorrect because the scenario focuses on how post-release vulnerability remediation disrupts ongoing development efforts, not on the effectiveness of quality assurance testing processes. Let's look at what happens when a critical vulnerability shows up in software that's already been released. Picture this. A financial services firm finds a serious flaw in a live product. Now, the developers who are working on new features have to stop everything, context switch, and go fix that flaw. That's a real operational hit. The correct answer is A. Disruption of current development cycles. When you pull developers off their current work to patch old code, you delay everything else they were building. Timelines slip, roadmaps shift, and the whole team loses momentum. Option B, increased network perimeter exposure, doesn't fit because this scenario is about internal development disruption, not network boundaries. Option C, loss of static analysis tool effectiveness, has nothing to do with the business impact of reassigning developer resources. And option D, reduced effectiveness of quality testing, misses the point. The scenario is about dev cycle disruption, not QA processes. Here's a WGU D487 OA exam tip for you. When a question describes developers stopping current work to fix released software, the answer is about development cycle disruption. The keyword pattern is stop and fix, or pull developers off projects. Quick recall hook. Stop and fix =, cycle disruption. 3. An organization uses cloud-hosted applications with multiple running versions. A vulnerability is discovered in one version, and attackers exploit it across all instances. Which unique challenge of cloud environments does this scenario highlight regarding software security management? A. Inability to perform static analysis. B. Lack of qualified security architects. C. Vulnerability propagation across versions. D. Excessive reliance on manual code reviews. Can you guess the answer? Correct answer, C. Vulnerability propagation across versions. Explanation. Option C is correct because in cloud environments, exposure in one application version can lead to exploitation across all versions unless strong segmentation controls exist, amplifying vulnerability impact. Option A is incorrect because static analysis can still be performed on cloud-hosted application code. The challenge described involves vulnerability spread across multiple running versions, not analysis limitations. Option B is incorrect because the scenario describes a technical challenge of managing vulnerabilities across multiple cloud application instances, not a staffing shortage of qualified security architects. Option D is incorrect because the core issue is vulnerability propagation across cloud application versions due to shared environments, not problems caused by excessive reliance on manual code reviews. This question hits on something unique about cloud environments that you need to understand. An organization is running cloud-hosted applications with multiple versions active at the same time. A vulnerability gets found in one version, and attackers exploit it across all instances. The correct answer is C. Vulnerability propagation across versions. Cloud environments often share infrastructure, libraries, and base images. So when one version has a flaw, that same flaw can exist in every other version, running on the same foundation. It spreads like wildfire unless you have strong segmentation controls in place. Option A, inability to perform static analysis, is wrong because you absolutely can run static analysis on cloud application code. Option B, lack of qualified security architects, describes a staffing problem, not the technical challenge of vulnerability spread. And option D, excessive reliance on manual code reviews, doesn't capture the real issue, which is how shared cloud infrastructure lets vulnerabilities propagate. Here's a WGU D487 OA exam tip for you. When a question mentions multiple versions or instances in the cloud being exploited from a single flaw, think propagation. The keywords multiple versions and exploit across signal vulnerability propagation. Quick recall hook: one flaw, all versions. Cloud amplifies the blast radius. 4. Industry reports indicate that over 70% of business security vulnerabilities are found within software applications rather than at network boundaries. Which strategic conclusion should an organization draw from this finding when allocating its security resources? A. Network firewalls are no longer necessary. B. Software development security deserves priority. C. Penetration testing should replace all controls. D. Application monitoring eliminates all risk. Do you know the answer? Correct answer: B. Software development security deserves priority. Explanation. Option B is correct because when most vulnerabilities originate in software applications rather than network boundaries, organizations should prioritize securing the software development process to address the primary source. Option A is incorrect because network firewalls remain an important layer of defense, even when most vulnerabilities originate in software. Eliminating them would remove a critical compensating security control. Option C is incorrect because penetration testing is one valuable technique, but cannot replace a comprehensive security program that includes secure development practices, training, and multiple defensive layers. Option D is incorrect because application monitoring is a reactive measure that detects issues after deployment. It does not eliminate all risk and cannot substitute for building security into the development process. Here's a stat that changes how organizations should think about security spending. Industry reports show that over 70% of business security vulnerabilities live inside software applications, not at network boundaries. That's a big deal. If most of your risk is sitting in your code, then that's where most of your security investment should go. The correct answer is B. Software development security deserves priority. You're not going to firewall your way out of bad code. Option A says network firewalls are no longer necessary. That's extreme and wrong. Firewalls still matter as one layer of defense, just not the primary one. Option C says penetration testing should replace all controls, which is way too narrow. Pen testing is one tool in the toolbox, not the whole program. And option D claims application monitoring eliminates all risk, which is wishful thinking. Monitoring catches problems after they happen. It doesn't prevent them. Here's a WGU D487 OA exam tip for you. When you see a stat like 70% of vulnerabilities are in software, the answer always points to prioritizing software development security. That percentage is your clue. Quick recall hook: 70% in code equals sign code, security first. 5. A major software vendor experiences a breach due to insecure code, resulting in regulatory fines, damaged customer trust, and public scrutiny. Beyond direct financial costs, which broader business consequence best captures why software security is considered a business decision? A. Increased developer hiring requirements. B. Mandatory adoption of agile methodology. C. Need for additional static analysis licenses. D. Reputation degradation and legal liability. Do you know the answer? Correct answer: D. Reputation degradation and legal liability. Explanation. Option D is correct because breaches from insecure code create legal issues, erode public trust, damage brand reputation, and generate regulatory liability, demonstrating that software security is fundamentally a business decision. Option A is incorrect because while a breach may eventually require more staff, the broader business consequence involves reputational harm and legal exposure, not simply an increased need for developers. Option B is incorrect because adopting agile methodology is a development process choice unrelated to the broader business consequences of reputation damage and legal liability from insecure software products. Option C is incorrect because purchasing additional static analysis tool licenses addresses only one narrow technical aspect of security and does not capture the broader business impact of reputation and legal consequences. This question gets at why software security is fundamentally a business decision, not just a technical one. A major vendor gets breached because of insecure code. The fallout includes regulatory fines, lost customer trust, and public scrutiny. Beyond the direct financial hit, the real damage is broader. The correct answer is D, reputation degradation and legal liability. Breaches don't just cost money in the moment. They erode brand value, trigger lawsuits, attract regulatory investigations, and drive customers to competitors. That's the kind of damage that shows up on quarterly earnings calls. Option A, increased developer hiring, is a possible side effect, but it doesn't capture the broader business consequence. Option B, mandatory adoption of Agile, makes no sense. Agile is a development methodology choice, not a breach consequence. Option C, additional static analysis licenses, is a narrow technical purchase that misses the big picture entirely. Here's a WGU D487 OA exam tip for you. When a question asks about broader business consequences, or beyond direct costs after a breach, reputation and legal liability is your answer. Those phrases are your trigger. Quick recall hook: breach =, brand damage plus lawsuits. 6. A security team is debating whether to focus resources on building security controls into the code during development, or deploying protective measures around the finished application after release. Which distinction best describes the difference between these two approaches in security terminology? A. Software security versus application security. B. Static analysis versus dynamic analysis. C. Threat modeling versus penetration testing. D. Quality assurance versus security testing. Can you guess the answer? Correct answer: A. Software security versus application security. Explanation. Option A is correct because software security focuses on building security into code during the development lifecycle, while application security focuses on protecting deployed software and its systems after release. Option B is incorrect because static and dynamic analysis are both testing techniques used within the development process, not terms describing the strategic distinction between proactive and post-release security approaches. Option C is incorrect because threat modeling and penetration testing are specific security activities, not overarching terms for the distinction between building security during development versus protecting after release. Option D is incorrect because quality assurance and security testing are related but different disciplines. They do not represent the specific distinction between securing code during development and protecting applications post-deployment. This is a vocabulary question you'll see on the exam, so get the terminology locked in. A security team is debating whether to focus on building security controls into the code during development or deploying protective measures around the finished application after release. These are two distinct approaches, and they have specific names. The correct answer is A. Software security versus application security. Software security means you're writing secure code from the ground up during the development lifecycle. Application security means you're wrapping protections around software that's already been built and deployed. Things like firewalls, intrusion detection systems, and web application firewalls. Option B, static versus dynamic analysis, describes two testing techniques, not the strategic distinction between proactive and reactive security. Option C, threat modeling versus penetration testing, names two specific activities, not the overarching philosophy difference. Option D, quality assurance versus security testing, mixes up related but different disciplines. Here's a WGU D487 OA exam tip for you. When you see building security into code versus protecting after release, that's software security versus application security. Those two phrases map directly to those two terms. Quick recall hook. Build in =, software security. Wrap around =, application security. 7. An organization deploys firewalls, intrusion detection systems, and web application firewalls around its released software products to mitigate threats. According to the textbook model, these protective measures are best classified as which type of security approach? A. Secure development lifecycle practices. B. Software security engineering controls. C. Application security compensating controls. D. Threat modeling validation activities. What do you think is the answer? Correct answer, C. Application security compensating controls. Explanation. Option C is correct because deploying protective measures, like firewalls and intrusion detection, around released software represents application security, which the text characterizes as compensating controls applied post-development. Option A is incorrect because secure development lifecycle practices involve integrating security activities during the software building process, not deploying external protective measures around already completed and released products. Option B is incorrect because software security engineering focuses on building security into the code during development, whereas the described measures protect the application environment after the software has been released. Option D is incorrect because threat modeling validation involves analyzing potential security threats and attack surfaces during development, not deploying protective technologies around software that has already been completed. An organization deploys firewalls, intrusion detection systems, and web application firewalls around its released software. These are all protections added after the code is already built and shipped. According to the textbook, the correct answer is C, application security compensating controls. The term compensating controls is key here. These measures don't fix what's wrong inside the code. They compensate for weaknesses by adding a protective layer around the application. They're reactive, not proactive. Option A, secure development lifecycle practices, is wrong because SDL happens during development, not after release. Option B, software security engineering controls, is wrong for the same reason. Software security is about building security into the code itself, not deploying external defenses afterward. Option D, threat modeling validation activities, doesn't fit because threat modeling happens early in development to identify risks before writing code. Here's a WGU D487 OA exam tip for you. When a question lists firewalls, IDS, or WAFs deployed around released software, the answer is application security compensating controls. The word around is your signal. It means after release, which means application security. Quick recall hook. Shields around the app =, compensating controls. 8. Early software like Unix code and the original TCP/IP stack was written with little consideration for security. When attacks grew more sophisticated, the industry initially responded with add-on solutions. Which answer best describes why these early add-on solutions were ultimately insufficient? A. They were too expensive to maintain. B. They required excessive developer training. C. They only worked in cloud environments. D. They failed to address insecure code. Can you guess the answer? Correct answer, D. They failed to address insecure code. Explanation. Option D is correct because add-on solutions like antivirus and firewalls provided external protection but never addressed the root cause, which was how the code itself was being developed and written. Option A is incorrect because the primary limitation of early add-on solutions was not their maintenance cost but their fundamental inability to fix the underlying problem of insecurely written software code. Option B is incorrect because the shortcoming of early security add-ons was not related to developer training requirements. It was that they treated symptoms rather than addressing insecure coding practices directly. Option C is incorrect because early add-on security solutions existed before widespread cloud computing adoption. Their limitation was failing to address the root cause of insecure software development practices. Let's go back to the early days of software development. Code like Unix and the original TCP/IP stack was written with almost zero thought about security. When attacks started getting more sophisticated, the industry's first response was to bolt on security after the fact. Things like antivirus software and firewalls. But those add-on solutions had a fundamental flaw. The correct answer is D. They failed to address insecure code. The root problem was never the lack of firewalls. The root problem was how the code itself was being written. Add-on solutions treated symptoms, not the disease. You can put all the locks you want on a house with walls made of cardboard. Option A says they were too expensive to maintain. Cost wasn't the core limitation. Option B says they required excessive developer training. That's not what made them fail. Option C says they only worked in cloud environments. Cloud computing didn't even exist yet when these add-on solutions were being deployed. Here's a WGU D487 OA exam tip for you. When a question asks why early add-on security solutions failed, the answer is always about the root cause: insecure code. The question pattern is, why were add-ons insufficient? Quick recall hook: add-ons treat symptoms, not the code. 9. A company wants to ensure its developers understand the distinction between building security into code and protecting released applications. Which team initiative best represents the software security approach rather than the application security approach? A. Deploying a web application firewall. B. Integrating a security development lifecycle into development. C. Monitoring production server logs daily. D. Running quarterly vulnerability scans. Do you know the answer? Correct answer: B. Integrating a security development lifecycle into development. Explanation. Option B is correct because integrating a security development lifecycle into the development process directly represents software security, which focuses on building security into the code during its creation. Option A is incorrect because deploying a web application firewall is an application security measure that protects released software from external threats rather than building security into the code during development. Option C is incorrect because monitoring production server logs is a post-deployment operational security activity classified under application security, not a proactive software security practice during development. Option D is incorrect because running quarterly vulnerability scans is a post-release assessment activity that falls under application security, detecting issues in deployed systems rather than preventing them during development. A company wants developers to understand the difference between building security in and protecting apps after release. The question asks which initiative represents the software security approach. The correct answer is B, integrating an SDL into development. An SDL, Security Development Lifecycle, means you're embedding security activities directly into how you write and build code. That's software security in action. Option A, deploying a web application firewall, is a protective measure you put around released software. That's application security, not software security. Option C, monitoring production server logs daily, is a post-deployment operational activity. You're watching the app run. That's application security territory. Option D, running quarterly vulnerability scans, is another post-release assessment technique. You're scanning deployed systems for problems, not preventing them during development. Here's a WGU D487 OA exam tip for you. Anytime the correct answer involves activities during development, like SDL, secure coding, or threat modeling, that's software security. Post-release actions like WAFs, monitoring, and scanning are application security. Quick recall hook. SDL = software security, UAF = application security. 10. The text argues that network and application security should come later in a comprehensive defense-in-depth program, with software security considered the first step. What reasoning best supports positioning software security as the foundational layer in this defense strategy? A. Only source-level security addresses root causes. B. Network controls are always ineffective alone. C. Application security tools are too costly. D. Penetration testing replaces all other controls. What do you think is the answer? Correct answer. A. Only source-level security addresses root causes. Explanation? Option A is correct, because the text states that network and application security are compensating controls, and only by addressing security at the source code level can organizations truly solve the root problems. Option B is incorrect because the text does not claim network controls are always ineffective. Rather, it positions them as compensating controls that should supplement, not replace, foundational software security practices. Option C is incorrect because the argument for prioritizing software security is not based on the cost of application security tools, but on the principle that addressing problems at their source is most effective. Option D is incorrect because penetration testing is one technique used in both software and application security. It does not replace other controls and is not the reason software security should be foundational. The text argues that software security should be the first step in a defense-in-depth strategy, with network and application security coming later. Why? The correct answer is A. Only source-level security addresses root causes. Network controls and application security measures are what the text calls compensating controls. They help, but they're patching around the problem rather than solving it. If the code itself is insecure, no amount of firewalls or monitoring will fully protect you. The only way to address the root cause is to fix the code. Option B says network controls are always ineffective alone. The text doesn't go that far. They're useful, just not sufficient by themselves. Option C says application security tools are too costly. Cost isn't the argument here. The argument is about addressing root causes. Option D says penetration testing replaces all other controls. That's absurd. Pen testing is one technique, not a substitute for a security program. Here's a WGU D487 OA exam tip for you. When a question asks why software security is the foundation of defense in depth, the answer is root cause. Everything else is a compensating control. Quick recall hook, source code = root cause, everything else = compensation. 11. A developer writes highly efficient, maintainable, and reusable code that passes all functional tests. However, the code allows unauthorized users to access sensitive application data. Based on the relationship between quality and security, which statement best describes this situation? A. The code is both secure and high quality. B. The code lacks quality and security equally. C. Quality code does not guarantee secure code. D. Security testing was performed incorrectly. What do you think is the answer? Correct answer. C. Quality code does not guarantee secure code. Explanation. Option C is correct because quality attributes like maintainability and reusability do not ensure security. Code can meet all quality standards while still allowing unauthorized access to sensitive application assets. Option A is incorrect because the scenario clearly describes code that meets quality standards but fails to prevent unauthorized access, meaning it cannot be classified as both secure and high quality simultaneously. Option B is incorrect because the code does possess quality attributes like efficiency and maintainability. The problem is specifically that it lacks security despite having strong quality characteristics in other areas. Option D is incorrect because the scenario illustrates a fundamental principle about the relationship between quality and security, not a failure in testing methodology or an error in the security testing process. A developer writes code that's efficient, maintainable, and reusable. It passes all functional tests. Sounds great, right? Except the code allows unauthorized users to access sensitive data. The correct answer is C. Quality code does not guarantee secure code. This is one of the most important distinctions in the course. Quality and security are measured differently. Quality looks at things like usability, maintainability, and reusability. Security looks at confidentiality, integrity, and availability. You can ace every quality metric and still have a gaping security hole. Option A says the code is both secure and high quality. Clearly not true since unauthorized access is happening. Option B says it lacks both quality and security equally. No, the quality attributes are fine. It's just the security that's missing. Option D says security testing was performed incorrectly. The scenario illustrates a principle about the quality-security relationship, not a testing failure. Here's a WGU D487 OA exam tip for you. When a question shows code that passes quality checks but has security flaws, the answer is about the quality-security distinction. Remember that these are complementary but separate. Quick recall hook. Quality is not security, they measure different things. 12. A security-focused developer writes code that authenticates every user transaction, logs all activity, and denies unauthorized requests. However, the code frequently returns incorrect results for legitimate users. Which principle about quality and security does this scenario demonstrate? A. Secure code does not guarantee quality code. B. Authentication eliminates all security risks. C. Logging always ensures code reliability. D. Authorization replaces quality testing needs. What do you think is the answer? Correct answer: A. Secure code does not guarantee quality code. Explanation. Option A is correct because code that implements strong security controls, like authentication and logging, may still fail quality standards if it does not return correct expected results for legitimate users. Option B is incorrect because while authentication is an important security control, the scenario demonstrates that implementing authentication alone does not address quality concerns like producing correct functional output. Option C is incorrect because logging is a security practice for tracking activities and does not ensure code reliability or correctness. The scenario shows that logged secure code can still fail quality expectations. Option D is incorrect because authorization controls access to resources based on user roles but does not replace the need for quality testing to verify that code produces correct functional results for users. Now let's flip the script from the last question. A security-focused developer writes code that authenticates every user transaction, logs all activity, and denies unauthorized requests. That's strong security work. But the code frequently returns incorrect results for legitimate users. The correct answer is A. Secure code does not guarantee quality code. Just because your code is locked down doesn't mean it works correctly. Security controls like authentication and logging are important, but they don't fix bad functional logic. If your application denies the bad guys but also gives wrong answers to the good guys, that's a quality failure even though the security is solid. Option B says authentication eliminates all security risks. No single control does that. Option C says logging always ensures reliability. Logging tracks. What happens? It doesn't make the code work correctly. Option D says authorization replaces quality testing. Authorization controls access. It has nothing to do with verifying functional correctness. Here's a WGU D487 OA exam tip for you. The exam loves to test the two-way relationship between quality and security. Quality doesn't guarantee security, and security doesn't guarantee quality. If a question shows secure code with bad functional output, the answer is this reverse relationship. Quick recall hook. Locked down but broken equals sign secure but not quality. 13. An organization is structuring its software engineering department and must decide how quality assurance and software security teams should be organized. According to the text, what organizational arrangement would best support effective collaboration between these two programs? A. Separate departments with annual reviews. B. Quality reports to security leadership only. C. Security operates as an external contractor. D. Both within software development engineering. Can you guess the answer? Correct answer, D. Both within software development engineering. Explanation. Option D is correct because the text states that quality and software security programs should ideally be part of the same organization, and both within the software development engineering department for optimal collaboration. Option A is incorrect because placing quality and security in completely separate departments with only annual reviews would not provide the close, ongoing collaboration that the text recommends during the development process. Option B is incorrect because having quality report exclusively to security leadership creates an imbalanced organizational structure that does not reflect the complementary, peer-level relationship the text describes between both programs. Option C is incorrect because operating security as an external contractor introduces distance from the development process, contradicting the text's recommendation for close integration within the same engineering organization. An organization is setting up its software engineering department and needs to figure out where quality assurance and security should sit in the org chart. The correct answer is D, both within software development engineering. The text is specific about this. Quality and software security programs should be part of the same organization, and ideally both within the software development engineering department. That proximity creates the close day-to-day collaboration needed to make both programs effective. Option A, separate departments with annual reviews, creates too much distance. Yearly check-ins aren't enough when you need real-time collaboration during sprints and releases. Option B, quality reports to security leadership only, creates an imbalanced structure. Quality and security should be peers, not one subordinate to the other. Option C, security operates as an external contractor, pushes security outside the development team, which is the opposite of what the text recommends. Here's a WGU D487 OA exam tip for you. When a question asks about organizing QA and security teams, the answer is same department, close collaboration. The text specifically says both should be within software development engineering. Quick recall hook. Same roof equal sign, better collaboration. QA and security under one engineering org. 14. The text emphasizes that quality and security complement each other and that you cannot have one without the other. When considering how quality is measured compared to security, which distinction accurately reflects how these two attributes differ in their evaluation criteria? A. Both use identical measurement frameworks. B. Quality measures usability, not confidentiality. C. Security focuses on reusability and maintenance. D. Quality and security share the same metrics. Can you guess the answer? Correct answer, B. Quality measures usability, not confidentiality. Explanation. Option B is correct because quality is measured in terms of ease of use, reusability, and maintainability, while security is measured through confidentiality, integrity, and availability, representing distinctly different evaluation criteria. Option A is incorrect because quality and security use fundamentally different measurement frameworks. Quality focuses on usability and maintainability, while security evaluates confidentiality, integrity, and availability as distinct attributes. Option C is incorrect because reusability and maintenance are quality attributes, not security attributes. Security is evaluated through confidentiality, integrity, and availability rather than code maintainability or reuse potential. Option D is incorrect because quality and security rely on different metrics entirely. Quality emphasizes functional characteristics like usability, while security emphasizes protective characteristics like confidentiality and data integrity. The text says quality and security complement each other, and you can't have one without the other, but they're measured differently. So what's the actual distinction? The correct answer is B, quality measures usability, not confidentiality. Quality is evaluated by things like ease of use, reusability, and maintainability. Security is evaluated through the CIA model, confidentiality, integrity, and availability. They're completely different measurement frameworks. Option A says both use identical measurement frameworks. That's the opposite of what the text says. Option C says security focuses on reusability and maintenance. Those are quality attributes, not security attributes. Option D says quality and security share the same metrics. Again, no, they have distinct evaluation criteria. Here's a WGU D487 OA exam tip for you. If a question asks how quality and security differ in measurement, remember the split. Quality gets usability, maintainability, and reusability. Security gets confidentiality, integrity, and availability. Quick recall hook. Quality =UMR, security =CIA. Different metrics for different goals. 15. A software architect argues that unlike quality, software security is not subjective because sensitive information is either exposed or it is not. How does this characteristic of security as a binary attribute influence the way development teams should prioritize secure coding practices? A. Teams can delay security to final testing. B. Security flaws are always easy to detect. C. No second chance demands early integration. D. Binary outcomes simplify security implementation. Can you guess the answer? Correct answer. C. No second chance demands early integration. Explanation. Option C is correct because the binary nature of security exposure means there is no partial credit or second chance. This demands integrating secure coding practices early, since failure results in definitive compromise. Option A is incorrect because the binary nature of security exposure actually argues against delaying security to final testing, since by that point, fundamental flaws may be deeply embedded and costly to remediate. Option B is incorrect because the fact that security outcomes are binary does not mean flaws are easy to detect. Many vulnerabilities remain hidden until exploited, despite security exposure being an either-or condition. Option D is incorrect because the binary nature of security outcomes does not simplify implementation. Instead, it raises the stakes since any failure to protect sensitive information results in complete exposure with no middle ground. A software architect makes an interesting argument. Unlike quality, security is not subjective. Sensitive information is either exposed or it isn't. There's no in-between. This binary nature of security has real consequences for how teams should work. The correct answer is C. No second chance demands early integration. When security fails, it fails completely. You don't get partial credit. Data is either compromised or it isn't. That means you can't afford to wait until final testing to think about security. because by then fundamental flaws might be baked so deep into the code that they're expensive and painful to rip out. You have to start early. Option A says teams can delay security to final testing. The binary nature actually argues against delay, not for it. Option B says security flaws are always easy to detect. Binary outcomes don't mean easy detection. Many vulnerabilities stay hidden until an attacker finds them. Option D says binary outcomes simplify implementation. They don't. They raise the stakes because any failure means total exposure. Animation Part 2. Here's a WGU D487 OA exam tip for you. When a question mentions the binary nature of security or no second chance, the answer points to early integration. There's no halfway point with security. Quick recall hook. Binary equals sign, no partial credit, equals sign, start early. 16. A development team must ensure that their application prevents unauthorized users from viewing sensitive customer records, while also guaranteeing that legitimate users can always access the system during business hours. Which two elements of the CIA model are directly addressed by these requirements? A. Integrity and authentication. B. Authorization and non-repudiation. C. Encryption and digital signatures. D. Confidentiality and availability. What do you think is the answer? Correct answer, D. Confidentiality and availability. Explanation. Option D is correct because preventing unauthorized viewing of sensitive records addresses confidentiality, while guaranteeing legitimate users can access the system during business hours directly addresses the availability requirement. Option A is incorrect because while integrity protects against improper modification and authentication verifies identity, the scenario specifically describes restricting data viewing and ensuring system uptime, which map to confidentiality and availability. Option B is incorrect because authorization is a supporting property of confidentiality, and non-repudiation is a component of integrity. Neither pair directly names the two primary CIA elements addressed in the scenario. Option C is incorrect because encryption and digital signatures are technical mechanisms used to achieve confidentiality and integrity. They are implementation tools, not the CIA model elements that the requirements address. A development team has two requirements: prevent unauthorized users from viewing sensitive customer records, and guarantee that legitimate users can always access the system during business hours. These map directly to two elements of the CIA model. The correct answer is D, confidentiality and availability. Preventing unauthorized viewing is confidentiality, controlling who can see data. Guaranteeing access during business hours is availability, making sure the system is up and usable when people need it. Option A, integrity and authentication. Integrity is about preventing unauthorized modification, and authentication is about verifying identity. Neither directly addresses viewing restrictions or uptime guarantees. Option B, authorization and non-repudiation. Authorization supports confidentiality, and non-repudiation is a component of integrity, but neither names the actual CIA elements being tested. Option C, encryption and digital signatures. These are technical mechanisms that support CIA. Elements, not CIA elements themselves. Here's a WGU D487 OA exam tip for you. When you see prevent unauthorized viewing, think confidentiality. When you see system always available or uptime, think availability. Map the scenario to CIA elements directly. Quick recall hook. Can't see it equals sign confidentiality. Can always use it equals sign availability. 17. According to 44 USC section 3542, integrity and information security is defined as guarding against improper information modification or destruction. Which additional assurance does the legal definition of integrity specifically include beyond preventing unauthorized changes? A. Ensuring non-repudiation and authenticity. B. Maintaining system uptime percentages. C. Restricting access to authorized users. D. Encrypting all data transmissions automatically. Do you know the answer? Correct answer, A. Ensuring non-repudiation and authenticity. Explanation. Option A is correct because the legal definition of integrity specifically includes ensuring information, non-repudiation, and authenticity, going beyond simply preventing unauthorized modification or destruction of data. Option B is incorrect because maintaining system uptime percentages falls under the availability element of the CIA model, not integrity, which focuses on protecting data from improper modification and ensuring authenticity. Option C is incorrect because restricting access to authorized users is a confidentiality concern that deals with controlling who can view information, not an integrity assurance about preventing improper data modification. Option D is incorrect because encrypting all data transmissions is a technical control that can support multiple CIA elements, but is not specifically included in the legal definition of integrity alongside non-repudiation and authenticity. According to the legal definition from 44 U.S.C. Section 3542, integrity means guarding against improper information modification or destruction. But the legal definition goes further than just preventing changes. The correct answer is A. Ensuring non-repudiation and authenticity. The law specifically adds non-repudiation and authenticity to the definition of integrity. Non-repudiation means you can prove someone took an action and they can't deny it. Authenticity means you can verify that data is genuine and came from a trusted source. These go beyond simply preventing unauthorized edits. Option B, maintaining system uptime percentages, falls under availability, not integrity. Option C, restricting access to authorized users, is a confidentiality concern about who can view data. Option D, encrypting all data transmissions, is a technical control that can support multiple CIA elements, but isn't specifically part of the legal definition of integrity. Here's a WGU D487 OA exam tip for you. When a question asks about the legal definition of integrity beyond preventing modification, the answer is non-repudiation and authenticity. The keyword 44 USC, or legal definition, paired with integrity points here. Quick recall hook. Integrity legally equals sign no tampering plus no denying plus genuine data. 18. A banking application must ensure that transaction data remains unchanged from the point of entry through transmission to the database and back to the user. Which combination of security mechanisms best supports this specific integrity requirement throughout the data lifecycle? A. Firewalls and intrusion detection systems. B. User training and access control lists. C. Data encryption and digital signatures. D. Antivirus software and log monitoring. Can you guess the answer? Correct answer, C. Data encryption and digital signatures. Explanation. Option C is correct because data encryption and digital signatures are specifically cited in the text as examples of mechanisms that maintain integrity by ensuring data remains unchanged throughout its entire lifecycle. Option A is incorrect because firewalls and intrusion detection systems are network-level and application-level protective controls that do not directly ensure data remains unchanged from entry through transmission to storage. Option B is incorrect because user training and access control lists support awareness and authorization, but do not provide the technical mechanisms needed to cryptographically verify that data has not been modified in transit. Option D is incorrect because antivirus software and log monitoring are detective and protective controls that do not directly ensure the integrity of transaction data throughout its journey from entry to database storage. A banking application needs transaction data to stay unchanged from the point of entry, through transmission to the database and back to the user. That's an integrity requirement. Data cannot be modified at any point in the lifecycle. The correct answer is C, data encryption and digital signatures. The text specifically names these two mechanisms as examples of maintaining integrity throughout the data lifecycle. Encryption protects data so it can't be read or altered in transit. Digital signatures let you verify that data hasn't been tampered with since it was signed. Together they cover the full journey. Option A, firewalls and IDS, are network-level and application-level protections. They don't directly verify that data is unchanged from entry to storage. Option B, user training and access control lists, support awareness and authorization, but don't cryptographically verify data hasn't been modified. Option D, antivirus and log monitoring, are detective and protective controls that don't directly ensure transaction data remains unaltered. Here's a WGU D487 OA exam tip for you. When a question describes data that must remain unchanged throughout its lifecycle, the answer involves encryption and digital signatures. The keywords are unchanged, from entry to storage and throughout. Quick recall hook: data unchanged == encryption plus digital signatures. 19. The text states that authorization and authentication are two properties supporting confidentiality. A developer implements strong authentication, but neglects role-based authorization. What security gap does this create for the application despite having verified user identities? A. Data integrity cannot be maintained. B. Verified users may access unauthorized data. C. System availability will be compromised. D. Encryption becomes completely ineffective. Do you know the answer? Correct answer: B. Verified users may access unauthorized data. Explanation: Option B is correct because authentication confirms identity, while authorization controls access privileges. Without proper role-based authorization, authenticated users can still view data beyond their permitted access level. Option A is incorrect because data integrity concerns improper modification or destruction of information, which is a separate CIA element from the confidentiality gap created by missing role-based authorization controls. Option C is incorrect because system availability relates to ensuring timely and reliable access to information. The absence of role-based authorization creates a confidentiality gap, not an availability problem. Option D is incorrect because encryption effectiveness is independent of the authorization gap described. Encryption protects data in transit or at rest, while authorization controls which authenticated users can access specific resources. The text says authorization and authentication are two properties that support confidentiality. Here's the scenario. A developer implements strong authentication but skips role-based authorization. What gap does that create? The correct answer is B. Verified users may access unauthorized data. Authentication confirms who you are. Authorization controls what you're allowed to do. If you have authentication but no authorization, you've verified that the person is who they claim to be, but you haven't restricted what they can access. So a junior employee could see executive-level financial data, or a customer could view another customer's records. That's a confidentiality gap. Option A, data integrity can't be maintained. Integrity is about preventing unauthorized modification, which is a separate concern. Option C, system availability will be compromised. Availability is about uptime, not access control. Option D, encryption becomes completely ineffective. Encryption works independently of whether you have authorization controls in place. Here's a WGU D487 OA exam tip for you. When a question says authentication is strong, but authorization is missing, the answer is always about verified users accessing data they shouldn't. The keyword pair is authentication without authorization. Quick recall hook. Auth without auths =, right person, wrong access. 20. The SDL has two primary goals: reducing the number of security vulnerabilities and privacy problems, and reducing the severity of remaining vulnerabilities. How does adherence to the CIA model throughout the development lifecycle contribute to achieving these dual SDL goals? A. It eliminates the need for post-release testing. B. It replaces quality assurance processes entirely. C. It focuses only on network boundary protection. D. It provides the security foundation for confidence. Can you guess the answer? Correct answer. D. It provides the security foundation for confidence. Explanation. Option D is correct because adhering to confidentiality, integrity, and availability throughout the SDL provides the foundational security framework that justifies high confidence. The code is secure and meets both goals. Option A is incorrect because following the CIA model during development does not eliminate the need for post-release testing. Ongoing assessment remains necessary even when security is built into the development lifecycle. Option B is incorrect because the CIA model complements quality assurance rather than replacing it. Quality and security are distinct but complementary attributes in the development process. Option C is incorrect because the CIA model applies throughout the entire software development lifecycle at the code level, not just at network boundaries, which are considered compensating controls applied after deployment. The SDL has two main goals: reduce the number of security vulnerabilities and privacy problems, and reduce the severity of the ones that remain. The question asks how the CIA model contributes to those goals throughout development. The correct answer is D. It provides the security foundation for confidence. When you apply confidentiality, integrity, and availability principles throughout the entire SDL, you're building a foundation that gives you justifiable confidence. The code is secure. It's not a guarantee, nothing is, but it's the structured basis for believing the software meets both goals of fewer vulnerabilities and lower severity. Option A says it eliminates the need for post-release testing. Applying CIA during development doesn't remove the need for ongoing assessment after release. Option B says it replaces quality assurance entirely. The text specifically says quality and security complement each other. They don't replace each other. Option C says it focuses only on network boundary protection. CIA applies at the code level throughout the SDL, not just at network boundaries. Here's a WGU D487 OA exam tip for you. When a question connects CIA to the SDL's dual goals, the answer is about providing a security foundation. Neither eliminates nor replaces will be correct. Those are too absolute. Quick recall hook. CIA plus SDL =, foundation for confidence. 21. A software security architect is tasked with identifying potential security threats, determining their risk levels, and establishing mitigations before any code is written. Which SDL activity does this scenario describe, and why is performing it early in the project lifecycle considered critical? A. Threat modeling for early cost savings. B. Penetration testing for vulnerability detection. C. Static analysis for code defect identification. D. Dynamic testing for runtime error discovery. Do you know the answer? Correct answer, A. Threat modeling for early cost savings. Explanation. Option A is correct because threat modeling identifies potential security threats and mitigations before code is committed, leading to significant cost savings by resolving security design issues early in the project lifecycle. Option B is incorrect because penetration testing evaluates the security of an already developed application by simulating attacks, not by identifying and mitigating potential threats before any code has been written. Option C is incorrect, because static analysis examines existing source code for common coding defects and poor development hygiene, requiring code to already exist rather than operating before code commitment begins. Option D is incorrect because dynamic testing requires running actual code to discover runtime errors and vulnerabilities, making it a later stage activity rather than a pre-coding threat identification and mitigation process. Let's talk about one of the most valuable activities in the entire SDL, threat modeling. A software security architect is asked to identify potential security threats, figure out how risky they are, and establish mitigations before a single line of code gets written. The correct answer is A. Threat modeling for early cost savings. Threat modeling happens at the design phase before code is committed. You're sitting down with your team, thinking through what could go wrong, how an attacker might exploit the system, and what you can do about it up front. The cost savings come from catching design-level security issues early, when they're cheap to fix. Option B, penetration testing, is done against software that already exists. You can't pen test code that hasn't been written yet. Option C, static analysis, also requires existing source code. It scans what's already there for coding defects. Option D, dynamic testing, needs running code to find runtime errors. None of these three work before code exists. Here's a WGU D487 OA exam tip for you. When a question mentions identifying threats before code is written, the answer is threat modeling. The phrase before any code is your trigger. Quick recall hook, before code =sign threat model. 22. The text describes three categories of threats based on intentionality: unintentional, intentional but non-malicious, and malicious. Among these categories, which distinction is critical for understanding how attacks against software are realized in practice? A. All three categories cause equal damage. B. Unintentional threats are the most dangerous. C. Only malicious threats are realized by attacks. D. Non-malicious threats cannot compromise security. Do you know the answer? Correct answer. C. Only malicious threats are realized by attacks. Explanation. Option C is correct, because although threats in all three categories can compromise software security, the text explicitly states that only malicious threats, which are assumed to be intentional, are actually realized through attacks. Option A is incorrect because the three threat categories do not cause equal damage. They differ in intentionality, and only malicious threats manifest as actual attacks, while the others compromise security through different mechanisms. Option B is incorrect because the text does not rank unintentional threats as most dangerous. It specifically distinguishes malicious threats as the only category realized by attacks, giving them unique significance in threat analysis. Option D is incorrect because the text states that threats in all three categories have the potential to compromise software security. Non-malicious threats can still cause security problems, even though they are not realized as attacks. The text breaks threats into three categories based on intentionality: unintentional, intentional but non-malicious, and malicious. All three can compromise software security, but there's a critical distinction. The correct answer is C. Only malicious threats are realized by attacks. The text makes this point directly. While all three categories can cause problems, only malicious threats, which are assumed to be intentional, actually turn into attacks. An unintentional threat might be a developer accidentally leaving a debug port open. An intentional non-malicious threat could be a sysadmin bypassing a control to meet a deadline. But an attack, that takes malicious intent. Option A says all three categories cause equal damage. The text doesn't claim that. They differ in how they materialize. Option B says unintentional threats are the most dangerous. The text doesn't rank them that way. Option D says non-malicious threats cannot compromise security. They absolutely can, they just don't manifest as attacks. Here's a WGU D487 OA exam tip for you. When a question asks about the relationship between threat categories and attacks, remember that all three compromise security, but only malicious threats become attacks. The keyword realized by attacks maps to malicious intent. Quick recall hook. All three compromise only malicious attacks. 23. A security team identifies all entry points and exit points of their application that may be accessible to attackers. They then exercise all code paths connected to these points during testing. Which security concept does this testing strategy specifically target? A. Confidentiality enforcement boundaries. B. Static analysis taint tracking scope. C. Security development lifecycle compliance. D. The application's attack surface. What do you think is the answer? Correct answer, D. The application's attack surface. Explanation. Option D is correct because the attack surface consists of all entry and exit points accessible to attackers, and thorough testing requires exercising all code paths connected to these points to validate security. Option A is incorrect because confidentiality enforcement boundaries relate to controlling access to sensitive information, not the specific practice of identifying and testing all attacker-accessible entry and exit points in code. Option B is incorrect because static analysis, taint tracking examines data flow for unsanitized inputs within code, which is a different technique from actively testing all code paths associated with application entry and exit points. Option C is incorrect because while testing the attack surface supports SDL compliance, the specific concept of identifying and exercising all attacker-accessible entry and exit points is distinctly called the attack surface. A security team identifies every entry point and exit point of their application that could be accessible to attackers, then tests all code paths connected to those points. What concept does this describe? The correct answer is D, the application's attack surface. The attack surface is the total collection of entry and exit points an attacker could potentially reach. Think of it like mapping every door, window, and vent in a building. Once you've mapped them, you test every hallway and room connected to those openings. That's what thorough attack surface testing looks like. Option A, confidentiality enforcement boundaries, relates to controlling who sees sensitive data. That's not what this testing strategy targets. Option B, static analysis taint tracking scope, describes a specific technique for tracing unsanitized inputs through code. Related but much narrower. Option C, SDL compliance, is a process goal, not the specific security concept of mapping and testing all accessible entry points. Here's a WGU D487 OA exam tip for you. When a question mentions identifying entry points and exit points accessible to attackers, the answer is attack surface. Those two phrases together are dead giveaways. Quick recall hook. Entry points plus exit points equals sign attack surface. 24. The text emphasizes that effective threat modeling requires getting into the mind of the hacker, which demands a special breed of professional. Why does the text argue that quality assurance professionals, despite their testing skills, are typically insufficient for this specific task? A. They lack access to security testing tools. B. They think like customers, not adversaries. C. They only perform automated scanning tasks. D. They refuse to collaborate with developers. What do you think is the answer? Correct answer, B. They think like customers, not adversaries. Explanation. Option B is correct because the text states that quality assurance professionals typically have customer perspectives in mind rather than hacker perspectives, limiting their ability to imagine all possible attack vectors. Option A is incorrect because the limitation is not about access to tools. Quality assurance professionals may have security tools available, but still approach testing from a customer-centric rather than adversarial threat perspective. Option C is incorrect because quality assurance professionals perform many types of testing beyond automated scanning. Their limitation for threat modeling is their customer-oriented mindset rather than their testing methodology choices. Option D is incorrect because the text does not suggest quality assurance. Professionals refuse to collaborate with developers. Their limitation is thinking from a user perspective rather than adopting the adversarial mindset needed for threat modeling. Threat modeling requires getting into the mind of the hacker, and the text says that demands a special breed of professional. So why aren't QA professionals enough? The correct answer is B, they think like customers, not adversaries. QA testers are trained to validate that software works correctly for the user. They test from a customer perspective. Does the button work? Does the form submit? Does the report generate? But threat modeling requires an adversarial mindset. You need someone who thinks about how to break things, bypass controls, and exploit weaknesses. Those are fundamentally different mental models. Option A says they lack access to security tools. That's not the limitation. You can hand a QA tester every security tool on the market, but if they're still thinking like a customer, they'll miss what an attacker would find. Option C says they only do automated scanning. QA testers do far more than just scanning, but their approach is still user-centric. Option D says they refuse to collaborate with developers. The text says nothing of the sort. Here's a WGU D487 OA exam tip for you. When a question asks why QA professionals can't do threat modeling effectively, the answer is about mindset, not tools or process. Customer thinking versus adversarial thinking. Quick recall hook. QA thinks customer, threat modeling thinks hacker. 25. Code restricted to local access by an administrator has a smaller attack surface than code exposed to remote access by an anonymous user. Which underlying principle about attack surfaces does this comparison demonstrate regarding how accessibility affects security risk? A. Accessibility increases the attack surface. B. Local access is always completely secure. C. Remote code requires no additional testing. D. Administrator access eliminates all threats. What do you think is the answer? Correct answer. A. Accessibility increases the attack surface. Explanation. Option A is correct because the text explicitly states that accessibility increases the attack surface. The more accessible code is to external or anonymous users, the larger the potential attack surface becomes. Option B is incorrect because local access being more restricted does not make it completely secure. It simply results in a smaller attack surface compared to remotely accessible code, but vulnerabilities can still exist locally. Option C is incorrect because remote code actually requires more extensive testing due to its larger attack surface. Greater accessibility to anonymous users creates more entry points that must be validated through security testing. Option D is incorrect because administrator access does not eliminate all threats. It simply represents a more restricted access model with a smaller attack surface, but administrators can still introduce or encounter security vulnerabilities. Code that only a local administrator can access has a smaller attack surface than code exposed to remote anonymous users. Why? The correct answer is A. Accessibility increases the attack surface. The more people who can reach your code, and the easier it is to reach, the bigger your attack surface becomes. Local admin-only code has a narrow attack surface. One person, physical, or VPN access required. Code open to anonymous users on the internet. That's a massive attack surface. Every endpoint, every parameter, every input field is an opportunity for an attacker. Option B says local access is always completely secure. No, it's more restricted, but not invulnerable. Option C says remote code requires no additional testing. The opposite is true. More accessible code needs more testing. Option D says administrator access eliminates all threats. administrators can still make mistakes or have their credentials compromised. Here's a WGU D487 OA exam tip for you. When a question compares local versus remote access and asks about attack surfaces, the answer ties accessibility to surface size. More accessible means bigger attack surface. Quick recall hook. More access equals more attack surface. 26. An organization wants to adopt a security-focused development process that reduces software maintenance costs and increases reliability for security-related defects. The process should be integrated into their existing development workflow rather than operating separately. Which development methodology best matches this description? A. Traditional quality assurance testing. B. Post-release vulnerability management. C. Security Development Lifecycle. D. Network perimeter defense strategy. Do you know the answer? Correct answer: C. Security Development Lifecycle. Explanation: Option C is correct because the Security Development Lifecycle is specifically defined as a software development process designed to reduce maintenance costs and increase reliability of software concerning security-related bugs integrated into development. Option A is incorrect because traditional quality assurance testing focuses on functional correctness and usability rather than being a dedicated security-focused development process that reduces security-related maintenance costs. Option B is incorrect because post-release vulnerability management addresses security problems after software is deployed, not during development, and typically increases costs rather than reducing maintenance expenditures over time. Option D is incorrect because a network perimeter defense strategy protects deployed systems from external threats and is not a software development process that integrates security practices into the coding lifecycle. An organization wants a security-focused development process that cuts maintenance costs, improves reliability for security defects, and integrates into their existing workflow. The correct answer is C. Security Development Lifecycle. The SDL is specifically designed for this. It's not a standalone program that runs in parallel to your development. It weaves directly into how you build software. The result is fewer security bugs, lower maintenance costs, and more reliable software from a security perspective. Option A, traditional QA testing, focuses on functional correctness and usability. It catches whether things work, not whether they're secure. Option B, post-release vulnerability management, addresses problems after deployment. That increases costs rather than reducing them. Option D, network perimeter defense, protects deployed systems from outside threats. It's not a development process at all. Here's a WGU D487 OA exam tip for you. When a question describes a process that reduces security maintenance costs and integrates into existing development, the answer is SDL. The combination of reduced costs plus integrated into development is your signal. Quick recall hook: integrated security process equals SDL. 27. The SDL has two primary goals that work together to improve the overall security posture of developed software. The first goal focuses on reducing the quantity of problems, while the second addresses remaining issues. Which pair accurately states both SDL goals in their correct relationship? A. Reduce vulnerability count and severity. B. Eliminate all bugs and improve performance. C. Increase testing speed and code coverage. D. Remove legacy code and modernize frameworks. Do you know the answer? Correct answer: A. Reduce vulnerability count and severity. Explanation: Option A is correct because the SDL's dual goals are explicitly stated as reducing the number of security vulnerabilities and privacy problems, while also reducing the severity of any vulnerabilities that remain. Option B is incorrect because the SDL does not claim to eliminate all bugs, which is practically impossible. Its goals specifically target reducing the number and severity of security vulnerabilities rather than achieving perfection. Option C is incorrect because increasing testing speed and code coverage are operational metrics for development efficiency, not the stated strategic goals of the Security Development Lifecycle regarding vulnerability management. Option D is incorrect because removing legacy code and modernizing frameworks are infrastructure improvement activities, not the core goals of the SDL, which focus on reducing vulnerability count and severity. The SDL has two primary goals that the text states explicitly. The correct answer is A, reduce vulnerability count and severity. Goal 1, reduce the number of security vulnerabilities and privacy problems in the software. Goal 2, reduce the severity of any vulnerabilities that still make it through. Notice the text doesn't say eliminate, it says reduce. That's a realistic, pragmatic target. Option B says eliminate all bugs and improve performance. Elimination is unrealistic, and performance isn't an SDL goal. Option C says increase testing speed and code coverage. Those are operational metrics, not SDL's strategic goals. Option D says remove legacy code and modernize frameworks. That's an infrastructure activity with no connection to the SDL's stated purpose. Here's a WGU D487 OA exam tip for you. When a question asks about SDL goals, remember the two R's, reduce the number and reduce the severity. If an option says eliminate or all, it's probably wrong. Quick recall hook. SDL = 2 reduces. Fewer vulns plus lower severity. 28. In January 2002, Microsoft software development groups began security pushes to improve existing code. This effort eventually led to a mandatory company-wide security policy established 2 years later. Which team at Microsoft formed the foundational concepts that became the Microsoft Security Development Lifecycle? A, the Windows Defender Engineering Group. B, the Azure Cloud Security Division. C, the Office Productivity Development Team. D, the Trustworthy Computing Team. Do you know the answer? Correct answer. D, the Trustworthy Computing Team. Explanation. Option D is correct because under the Security Push Directive, the Trustworthy Computing Team at Microsoft formed the concepts that led to the Microsoft Security Development Lifecycle, which became mandatory policy in 2004. Option A is incorrect because the Windows Defender Engineering Group is focused on endpoint security products, not the foundational security development process concepts that led to the creation of the Microsoft SDL. Option B is incorrect because the Azure Cloud Security Division addresses cloud infrastructure security concerns and was not the team that created the foundational concepts leading to the Microsoft Security Development Lifecycle in 2004. Option C is incorrect because the Office Productivity Development Team focuses on building productivity applications and was not responsible for forming the trustworthy computing concepts that became the Microsoft SDL. In January 2002, Microsoft's development group started security pushes to improve existing code. 2 years later, this effort became a mandatory company-wide security policy. Which team at Microsoft formed the foundational concepts behind the Microsoft SDL? The correct answer is D, the Trustworthy Computing Team. Under the Security Push Directive, the Trustworthy Computing Team developed the concepts that evolved into what we now call the Microsoft Security Development Lifecycle. It became mandatory policy across Microsoft in 2004. Option A, the Windows Defender Engineering Group, is focused on endpoint security products like anti-malware. They build security products, not the SDL framework. Option B, the Azure Cloud Security Division, deals with cloud infrastructure security. Azure wasn't even a thing when the SDL was being developed in 2002. Option C, the Office Productivity Development Team, builds Office products like Word and Excel. They weren't the ones creating security development methodology. Here's a WGU D487 OA exam tip for you. When a question asks about the origin of the Microsoft SDL, the answer is trustworthy computing. The year 2002 paired with Microsoft Security Push always leads to that team. Quick recall hook. Microsoft SDL origin =, trustworthy computing. 2002 push, 2004 mandatory. 29. The SDL methodology is sometimes confused with the standard software development lifecycle because both share similar terminology. However, the text draws a clear distinction between their primary purposes. What is the SDL specifically aimed at developing? A. Quality software with maximum features. B. Secure software through best practices. C. Rapid prototypes for market testing. D. Cost-efficient code for small teams. What do you think is the answer? Correct answer. B. Secure software through best practices. Explanation. Option B is correct because the text explicitly states that SDL methodology is really aimed at developing secure software, not necessarily quality software, distinguishing it clearly from standard development life cycles. Option A is incorrect because developing quality software with maximum features is the focus of standard software development life cycles, not the SDL, which specifically targets security as its primary objective. Option C is incorrect because rapid prototyping for market testing is a product development strategy unrelated to the SDL, which focuses specifically on integrating security best practices throughout the development process. Option D is incorrect because building cost-efficient code for small teams describes a development efficiency goal, not the purpose of the SDL, which specifically aims to produce secure software through systematic security practices. People sometimes confuse SDL with the standard software development lifecycle because the terms sound similar, but they serve different purposes. The correct answer is B, secure software through best practices. The SDL is specifically aimed at developing secure software, not quality software, not feature-rich software. Secure software. The standard software development lifecycle focuses on building quality software with the right features. The SDL focuses on making sure that software is protected against security threats through systematic best practices. Option A, quality software with maximum features, is the standard SDLC goal, not the SDL goal. Option C, rapid prototypes for market testing, is a product development strategy that has nothing to do with security. Option D, cost-efficient code for small teams, describes an efficiency target, not a security methodology. Here's a WGU D487 OA exam tip for you. When a question asks what distinguishes SDL from the standard SDLC, the answer is the security focus. SDLC builds quality software. SDL builds secure software. Quick recall hook. SDLC = quality. SDL = security. 30. The authors define their use of the term SDL as representing a secure development process composed of multiple inputs. These include comparative research on existing models, practical experience from development organizations, and one additional critical factor. Which factor completes the author's SDL definition? A. Business realities of development austerity. B. Academic theoretical framework validation. C. Government regulatory compliance mandates. D. Open source community contribution standards. Do you know the answer? Correct answer. A. Business realities of development austerity. Explanation. Option A is correct because the authors explicitly include the business realities of today's development. Austerity requirements coupled with increasing demands for securing code as a key input to their SDL definition. Option B is incorrect because while the authors reference academic research as one input, the specific third factor they emphasize is business realities and development austerity, not a separate academic theoretical framework validation. Option C is incorrect because government regulatory compliance mandates are external pressures that may motivate SDL adoption, but the authors specifically cite business realities and development austerity as their third defining input. Option D is incorrect because open source community contribution standards are not mentioned as an input to the author's SDL definition, which specifically emphasizes business realities and cost-effective security practices. The authors define their SDL as a secure development process built from multiple inputs. Two of those inputs are comparative research on existing models and practical experience from development organizations. The question asks for the third. The correct answer is A, business realities of development austerity. The authors specifically call out the business realities of today's development environment, where budgets are tight and demands for secure code keep growing. This isn't an academic exercise. The SDL has to work in the real world where teams are stretched thin and money is limited. Option B, academic theoretical framework validation, sounds scholarly, but the third input is specifically about practical business pressures, not academic theory. Option C, government regulatory compliance mandates, might motivate SDL adoption, but the authors are talking about the internal business reality of doing more with less. Option D, open source community contribution standards, isn't mentioned as an input to their SDL definition at all. Here's a WGU D487 OA exam tip for you. When a question asks what completes the SDL definition beyond research and experience, the answer is business realities. The word austerity paired with development is your signal. Quick recall hook, SDL inputs equal sign research plus experience plus business reality. 31. Barry Boehm's early research established that defects found in fielded software cost dramatically more to correct than those identified during development. Later data from Fortify in 2008 reinforced this principle with updated figures. What cost ratio did Fortify's data indicate between fixing flaws at the requirements level versus fixing them in fielded software? A, 5 times less expensive at requirements. B, 20 times less expensive at requirements. C, exactly 200 times less at requirements. D, up to 100 times less at requirements. What do you think is the answer? Correct answer. D, up to 100 times less at requirements. Explanation. Option D is correct because Fortify's 2008 data specifically indicates that correcting security flaws at the requirements level costs up to 100 times less than correcting the same flaws in fielded software. Option A is incorrect because the 5-to-1 ratio was cited by Boehm for small non-critical systems as a revised lower bound estimate, not the figure presented by Fortify's 2008 data on security flaw remediation costs. Option B is incorrect because Fortify's research did not cite a 20 times cost ratio. Their data indicated that requirements level corrections cost up to 100 times less than fixing security flaws in deployed software. Option C is incorrect because the 200 times figure relates to Boehm's original 1988 upper bound estimate for general defects found in the field, not the specific Fortify 2008 data on security flaw remediation. Barry Boehm's early research showed that defects in fielded software cost dramatically more to fix than ones caught during development. Later, Fortify's 2008 data backed this up with specific numbers. What cost ratio did Fortify find? The correct answer is D, up to 100 times less at requirements. Fortify's data specifically shows that catching and fixing a security flaw at the requirement stage costs up to 100 times less than fixing it after the software is already deployed. That's a staggering difference. Option A, 5 times less, refers to Boehm's revised lower bound estimate for small non-critical systems, a different data point. Option B, 20 times less, isn't a figure cited by Fortify's research. Option C, exactly 200 times, is closer to BIRM's original 1988 upper bound estimate for general defects, not the fortified 2008 security-specific data. Here's a WGU D487 OA exam tip for you. When a question specifically cites fortified 2008 data and asks about the cost ratio for security flaws, the answer is up to 100 times. Don't confuse it with BIRM's different figures. Quick recall hook. Fortified 2008 = 100x, BIRM original = 200x, BIRM revised = 5x. 32. A software vendor releases a product with an undiscovered security flaw. 6 months later, the vulnerability is found, and the vendor must develop and distribute a patch. Beyond the direct cost of patch development, which additional risk does the text specifically identify about the patching process itself? A. Patches always require complete code rewrites. B. Patches can introduce new vulnerabilities. C. Patching automatically voids software warranties. D. Patches eliminate the need for future testing. Can you guess the answer? Correct. Answer B. Patches can introduce new vulnerabilities. Explanation. Option B is correct, because the text explicitly warns that patches can contain yet more vulnerabilities, and the authors have seen patches that fix one security problem, but open or reopen other security issues. Option A is incorrect because patches are targeted fixes for specific issues and do not require complete code rewrites. The text warns about the risk of patches introducing new vulnerabilities rather than requiring full redevelopment. Option C is incorrect because the text does not discuss software warranties being voided by patching. Its concern is that patches may not receive adequate attention and can introduce additional security problems beyond the original flaw. Option D is incorrect because the text argues the opposite. Patches often do not go through the regular software development lifecycle, suggesting they actually need more testing rather than eliminating the need for it. A software vendor releases a product with a hidden security flaw. 6 months later, the vulnerability gets discovered and the vendor has to build and ship a patch. Beyond the cost of making the patch itself, the text identifies another specific risk. The correct answer is B. Patches can introduce new vulnerabilities. The authors are blunt about this. They've personally seen patches that fix one security problem, but open or reopen others. When a patch gets rushed out, it often doesn't go through the full development lifecycle. That shortcuts testing, code review, and quality gates. The fix for one hole can literally create 2 new ones. Option A says patches always require complete rewrites. Patches are targeted fixes, not total rewrites. Option C says patching voids software warranties. The text doesn't discuss warranties at all. Option D says patches eliminate the need for future testing. The text argues the exact opposite. The patches need more testing, not less. Here's a WGU D487 OA exam tip for you. When a question asks about the risk of the patching process itself, the answer is introducing new vulnerabilities. The text warns that patches can create more problems. Quick recall hook. Fix 1, break 2. Patches can add vulns. 33. The cost model depicted in the text shows that addressing software problems during the software development lifecycle phases starts at approximately 20% additional cost and escalates through later phases. At the post-release stage, the cost increase reaches its maximum. What approximate percentage increase does the model show for post-release remediation? A. 200% above baseline cost. B. 300% above baseline cost. C. 50% above baseline cost. D. 100% above baseline cost. Can you guess the answer? Correct answer A. 200% above baseline cost. Explanation. Option A is correct because the cost model figure in the text shows post-release remediation reaching approximately 200% above baseline cost, representing the highest cost tier in the escalation model. Option B is incorrect because the cost model in the text shows the post-release tier reaching approximately 200% above baseline, not 300%, which would overstate the figure depicted in the diagram. Option C is incorrect because 50% above baseline represents an earlier software development lifecycle phase cost tier in the model, not the post-release maximum that occurs when security problems must be fixed after the software has been deployed. Option D is incorrect because 100% above baseline represents a mid to late software development lifecycle phase in the cost model, which is below the post-release peak of approximately 200% shown in the figure. The text includes a cost model showing how fixing software problems escalates through SDLC phases. It starts at about 20% additional cost during early phases and climbs from there. At the post-release stage, it hits the peak. The correct answer is A, 200% above baseline cost. The model shows that post-release remediation reaches approximately 200% above baseline, the most expensive point in the entire life cycle. Option B, 300%, overstates the figure shown in the diagram. Option C, 50%, represents an earlier SDLC phase, not the post-release peak. Option D, 100%, represents a mid to late phase in the model, below the post-release maximum. Here's a WGU D487 OA exam tip for you. When a question asks about the maximum cost percentage in the cost model, the answer is 200% at post-release. Remember the escalation. It starts at 20% and climbs to 200%. Quick recall hook. Post-release peak, =200% above baseline. 34. Software owners and users who receive security patches do not always apply them promptly, creating a persistent window of exposure. Which broader security challenge does this inconsistent patch application behavior create for software vendors trying to protect their user base? A. Vendors must abandon legacy product support. B. All users automatically receive patch benefits. C. Vulnerable software remains exposed indefinitely. D. Patching eliminates every known vulnerability. What do you think is the answer? Correct answer, C. Vulnerable software remains exposed indefinitely. Explanation. Option C is correct because the text specifically notes that patches are not always applied by owners or users of vulnerable software, meaning systems remain exposed to known vulnerabilities despite available fixes. Option A is incorrect because while patch challenges exist, the text does not state that vendors must abandon legacy support. Rather, it highlights that inconsistent user patch application leaves vulnerable software exposed. Option B is incorrect because the text explicitly states the opposite. Not all users apply patches, which means many systems do not receive the benefits of security fixes and remain vulnerable to exploitation. Option D is incorrect because even when patches are applied, they do not eliminate every vulnerability. The text warns that patches themselves can introduce new security issues while attempting to fix existing ones. Patches exist, but that doesn't mean people apply them. Software owners and users often delay or skip patches entirely, leaving their systems exposed. The correct answer is C. Vulnerable software remains exposed indefinitely. The text makes this point clearly. Patches aren't always applied. Some organizations postpone updates to avoid downtime. Some users don't even know patches are available. The result is a persistent window of exposure where known vulnerabilities remain exploitable. Option A says vendors must abandon legacy support. The text doesn't say that. Patching challenges exist, but they don't force vendors to drop legacy products. Option B says all users automatically receive patch benefits. That's the opposite of reality. Many systems stay unpatched. Option D says patching eliminates every known vulnerability. Even when patches are applied, the text warns they can introduce new issues. Here's a WGU D487 OA exam tip for you. When a question asks about the broader challenge of inconsistent patch application, the answer is persistent exposure. Systems stay vulnerable because people don't patch. Quick recall hook. Unpatched =, still exposed. 35. A company rushes to release an emergency security patch without following its standard development process. The patch resolves the reported vulnerability, but inadvertently creates 2 new security weaknesses. Which principle from the text does this scenario most directly illustrate? A. Emergency patches always improve overall security. B. Standard processes prevent all security issues. C. Security weaknesses only exist in legacy systems. D. Rushed patches create more problems than resolved. Can you guess the answer? Correct answer. D. Rushed patches create more problems than resolved. Explanation. Option D is correct because the text warns that companies cannot always give each patch the attention it deserves, and bypassing the regular development lifecycle can result in more security problems than the fix mitigates. Option A is incorrect because the scenario directly contradicts this claim. The text demonstrates that emergency patches developed outside standard processes can introduce additional vulnerabilities rather than improving security overall. Option B is incorrect because while standard processes significantly reduce risk, the text does not claim they prevent all security issues. It emphasizes that bypassing them during patching increases the likelihood of new problems. Option C is incorrect because security weaknesses can exist in any software, regardless of age. The scenario illustrates risks of rushed patch development rather than suggesting vulnerabilities are limited to legacy systems only. A company rushes out an emergency security patch without following its standard development process. The patch fixes the reported vulnerability, but accidentally creates 2 new security weaknesses. The correct answer is D. Rushed patches create more problems than resolved. The text is direct about this. Companies can't always give each patch the attention it deserves. When you skip the regular development lifecycle to get a fix out fast, you're trading thoroughness for speed. The result can be a patch that solves 1 problem while opening 2 more. Option A says emergency patches always improve security. This scenario directly contradicts that. Option B says standard processes prevent all security issues. Even standard processes can't prevent everything. The point is that bypassing them makes things worse. Option C says security weaknesses only exist in legacy systems. Weaknesses can appear in any software of any age. Here's a WGU D487 OA exam tip for you. When a question describes a rushed patch that creates new problems, the answer is about the danger of bypassing standard development processes. Rush and emergency combined with new weaknesses signal this answer. Quick recall hook. Rush the patch, multiply the problems. 36. A development team is evaluating tools that can examine application code without executing it to find common coding defects related to poor development practices. The tool they need uses a technique specifically designed to detect unfiltered or unsanitized inputs in the codebase. Which type of tool and technique matches this requirement? A. Dynamic analysis using runtime monitoring. B. Penetration testing with exploit simulation. C. Static analysis using taint analysis. D. Threat modeling with attack trees. Do you know the answer? Correct answer, C. Static analysis using taint analysis. Explanation. Option C is correct, because the text specifically states that static analysis tools use a technique called taint analysis to look for unfiltered or unsanitized inputs, which are described as the scourge of software security. Option A is incorrect because dynamic analysis requires actually running the code to identify runtime behavior issues, whereas the requirement specifies examining code without executing it to detect unsanitized input patterns. Option B is incorrect because penetration testing simulates real attacks against deployed applications and does not involve examining source code for unsanitized inputs using the taint analysis technique described in the scenario. Option D is incorrect because threat modeling with attack trees is a conceptual analysis approach for identifying potential threats and attack paths, not a tool-based technique for scanning source code for unsanitized inputs. A development team needs a tool that can examine application code without executing it, specifically to detect unfiltered or unsanitized inputs. The correct answer is C, static analysis using taint analysis. The text names this combination explicitly. Static analysis means you're examining source code without running it. Taint analysis is the specific technique within static analysis that traces data flow to find inputs that haven't been properly filtered or sanitized. The text calls unsanitized inputs the scourge of software security. So this is a big deal. Option A, dynamic analysis with runtime monitoring, requires actually running the code. The question says without executing it. Option B, penetration testing with exploit simulation, attacks deployed applications. It doesn't scan source code for unsanitized inputs. Option D, threat modeling with attack trees, is a conceptual design exercise, not a code scanning technique. Here's a WGU D487 OA exam tip for you. When a question mentions examining code without running it and detecting unsanitized inputs, the answer is static analysis with taint analysis. The word taint pairs with unsanitized. Quick recall hook. No execution plus unsanitized inputs =sign static plus taint. 37. While static analysis tools are effective at identifying common coding defects, they have significant limitations in what they can evaluate. A security team needs to assess whether the application's cryptographic libraries are properly designed and algorithms are correctly selected. Why is static analysis insufficient for this specific evaluation? A. Static tools cannot evaluate design flaws. B. Cryptographic libraries are always secure. C. Static tools only work on compiled binaries. Algorithm selection is a network concern. Can you guess the answer? Correct answer, A. Static tools cannot evaluate design flaws. Explanation. Option A is correct because the text explicitly states that static analysis tools cannot evaluate design and architectural flaws, including poorly designed cryptographic libraries or improperly selected algorithms, which are design-level decisions. Option B is incorrect because cryptographic libraries are not inherently always secure. Poor design and improper algorithm selection are real risks that static analysis tools simply cannot detect due to their design-level nature. Option C is incorrect because static analysis tools typically work on source code rather than only compiled binaries. Their limitation regarding cryptographic evaluation is about design-level analysis, not the format of code they examine. Option D is incorrect because algorithm selection is a software design concern within the development process, not a network concern. Static analysis tools cannot assess it because it represents an architectural decision beyond code-level defects. Static analysis tools are good at finding common coding defects, but they have real limitations. A security team needs to evaluate whether the application's cryptographic libraries are properly designed and the right algorithms were selected. Can static analysis handle this? The correct answer is A. Static tools cannot evaluate design flaws. The text says it plainly. Static analysis tools cannot evaluate design and architectural flaws. Choosing the wrong cryptographic algorithm or poorly designing a crypto library is a design-level decision, not a code-level defect. Static tools look at code patterns, not architectural choices. Option B says crypto libraries are always secure. That's dangerously wrong. Poor design in crypto libraries is a real and common problem. Option C says static tools only work on compiled binaries. Static analysis typically works on source code, not binaries. The limitation is about design analysis, not code format. Option D says algorithm selection is a network concern. Algorithm selection is a software design decision, not a network issue. Here's a WGU D487 OA exam tip for you. When a question asks why static analysis can't evaluate crypto design, the answer is that design flaws are outside static analysis scope. Design and architecture are beyond what code scanning can detect. Quick recall hook: static equals sign code defects, not design decisions. 38. A developer embeds a hard-coded password directly into the application source code for database connectivity. The security team expects their automated static analysis tool to flag this as a vulnerability during the next scan. Based on the text description of static analysis limitations, what is the likely outcome? A. The tool will flag it as a critical finding. B. The tool cannot identify embedded passwords. C. The tool will automatically remove the password. D. The tool will encrypt the password in place. Do you know the answer? Correct answer: B. The tool cannot identify embedded passwords. Explanation: Option B is correct because the text explicitly states that static analysis tools cannot identify passwords or magic numbers embedded in code, making this a recognized limitation of automated static analysis scanning. Option A is incorrect because the text specifically lists embedded passwords as something static analysis tools cannot detect. Therefore, the tool would not flag this hard-coded password as a critical finding during scanning. Option C is incorrect because static analysis tools analyze code for defects, but do not modify source code. They cannot automatically remove embedded passwords or make any changes to the codebase they are examining. Option D is incorrect because static analysis tools perform read-only examination of code to identify potential defects. They do not alter code by encrypting passwords in place or performing any remediation actions automatically. A developer hard-codes a password directly into the application source code for database connectivity. The security team expects their static analysis tool to catch this. Will it? The correct answer is B. The tool cannot identify embedded passwords. The text specifically lists embedded passwords and magic numbers as things static analysis tools cannot detect. This is a recognized limitation. The tool can find coding patterns like unsanitized inputs and buffer issues, but a password sitting in a string variable looks like any other string to the scanner. Option A says the tool will flag it as critical. That's the expected outcome, but the text says it won't happen. Static tools miss this. Option C says the tool will automatically remove the password. Static analysis is read-only. It examines code. It doesn't modify it. Option D says the tool will encrypt the password in place. Again, static tools don't alter code. They report findings, nothing more. Here's a WGU D487 OA exam tip for you. When a question asks whether static analysis can find hard-coded passwords, the answer is no. This is a specifically listed limitation. The keyword embedded passwords or magic numbers signals this gap. Quick recall hook: static analysis is blind to passwords in code. 39. A project manager must decide whether to use static analysis or dynamic analysis at an early development stage when the codebase is partially complete and not yet ready for full execution. Which advantage of static analysis makes it the more appropriate choice at this stage? A. It requires the code to be fully deployed. B. It only works during post-release audits. C. It needs complete runtime environment setup. D. It can be applied before code completion. Do you know the answer? Correct answer D. It can be applied before code completion. Explanation. Option D is correct because the text states that static analysis has the potential to be applied before a program reaches a level of completion at which testing can be meaningfully performed. Option A is incorrect because static analysis does not require code to be fully deployed. This describes a characteristic of dynamic analysis, or runtime testing, which needs executing code in a deployed or simulated environment. Option B is incorrect because static analysis is specifically valuable during early development phases, not limited to post-release audits. Its early applicability is one of its primary advantages over dynamic analysis techniques. Option C is incorrect because static analysis examines source code directly without requiring a complete runtime environment setup, which is a prerequisite for dynamic analysis that actually executes the running application. A project manager needs to choose between static and dynamic analysis early in development when the code base is only partially complete and not ready to run. The correct answer is D. It can be applied before code completion. This is one of static analysis's biggest advantages. The text says static analysis can be applied before a program reaches a level of completion where testing can be meaningfully performed. You don't need working running code. You can scan partial code module by module as developers write it. Dynamic analysis needs an executable application. You can't dynamically test code that doesn't run yet. Option A says static analysis requires fully deployed code. That's the opposite. Deployment is a dynamic analysis prerequisite. Option B says it only works during post-release audits. Static analysis shines during early development, not just post-release. Option C says it needs a complete runtime environment. Runtime environments are for dynamic analysis, not static. Here's a WGU D487 OA exam tip for you. When a question asks about choosing analysis tools for incomplete code, the answer is static analysis because it works before code completion. Partially complete or not yet running are your triggers. Quick recall hook. Incomplete code, static analysis works. 40. A security architect identifies a design flaw where the application confuses authentication with authorization, granting authenticated users access to resources beyond their privilege level. Static analysis tools did not detect this issue. Which fundamental limitation explains why this type of vulnerability escaped automated detection? A. The tools were misconfigured for the language. B. Design problems are beyond static tool scope. C. Authentication flaws require manual encryption. D. Authorization bugs only appear at runtime. Can you guess the answer? Correct answer, B. Design problems are beyond static tool scope. Explanation. Option B is correct because the text explicitly states that static analysis tools cannot point out design problems that might cause confusion between authentication and authorization, as these are architectural level flaws. Option A is incorrect because the failure to detect this design flaw is not due to tool misconfiguration. The text identifies confusion between authentication and authorization as a design problem inherently beyond static analysis capabilities. Option C is incorrect because authentication flaws do not require manual encryption to detect. The issue is that confusing authentication with authorization is a design-level problem that static analysis tools fundamentally cannot evaluate. Option D is incorrect because while some bugs manifest at runtime, the text specifically identifies authentication and authorization confusion as a design problem that static tools cannot detect, regardless of when the flaw becomes visible. A security architect finds a design flaw where the application confuses authentication with authorization, letting authenticated users access resources beyond their privilege level. The static analysis tool didn't catch it. Why? The correct answer is B. Design problems are beyond static tool scope. The text specifically says static analysis tools cannot point out design problems that might cause confusion between authentication and authorization. This is an architectural level flaw. The system was designed incorrectly. Static analysis looks at code patterns and syntax level defects. It doesn't understand whether your application's design correctly separates who you are from what you're allowed to do. That's a human judgment call. Option A says the tools were misconfigured. The failure isn't about configuration. It's a fundamental limitation of what static tools can evaluate. Option C says authentication flaws require manual encryption. That doesn't make sense. The issue is design confusion, not encryption. Option D says authorization bugs only appear at runtime. While some do, the text's point is that this is a design problem, not a runtime visibility issue. Here's a WGU D487 OA exam tip for you. When a question shows a design flaw that static analysis missed, the answer is always about static tools being limited to code-level defects. The text even names authentication, authorization confusion specifically. Quick recall hook. Auth versus auth's confusion equal signs. Design flaw equal sign beyond static. 41. A company invests heavily in automated security scanning tools to replace its experienced software security architects, believing automation alone can secure their development process. According to the text, why is this approach fundamentally flawed despite the speed advantages of automated tools? A. Tools cannot replace human security expertise. B. Automated tools eliminate all coding defects. C. Tools are a complete replacement for humans. D. Scanning tools work only on legacy systems. Can you guess the answer? Correct answer, A. Tools cannot replace human security expertise. Explanation. Option A is correct because the text explicitly states that although tools can pass through large quantities of code rapidly, they are no replacement for humans, and software security still requires human expertise. Option B is incorrect because automated tools have recognized limitations, including inability to detect design flaws, embedded passwords, and architectural problems, meaning they cannot eliminate all coding defects from an application. Option C is incorrect because the text directly contradicts this claim. It emphasizes that tools cannot substitute for the experience and adversarial thinking that seasoned software security architects and engineers provide to development. Option D is incorrect because automated scanning tools work on various code bases regardless of age. The text's point is about their fundamental limitation in replacing human expertise, not restrictions related to legacy system compatibility. A company decides to go all in on automated security scanning tools and get rid of their experienced software security architects. Automation is fast, right? Why pay for expensive humans? The text is pretty clear about why this thinking is flawed. The correct answer is A. Tools cannot replace human security expertise. Yes, automated tools can chew through massive code bases at a speed no human can match. But speed isn't everything. We've already covered that static analysis can't catch design flaws, embedded passwords, or architectural problems. Those gaps require human judgment, experience, and adversarial thinking. A seasoned security architect looks at a system and thinks about how an attacker would approach it. Tools can't replicate that instinct. Option B says automated tools eliminate all coding defects. We've seen multiple questions now proving that's false. Static tools miss passwords, design flaws, and more. Option C says tools are a complete replacement for humans. The text directly contradicts this. Option D says scanning tools only work on legacy systems. Tools work on any code base. The limitation is about human expertise, not system age. Here's a WGU D487 OA exam tip for you. When a question pits tools against human expertise, the answer always sides with humans. Tools assist, they don't replace. The phrase replace experienced architects or automation alone is your red flag. Quick recall hook. Tools speed up, humans think deep. You need both. 42. The text identifies training as a critical element of the security development lifecycle that yields multiple benefits for the development organization. Among these benefits, which outcome does an effective security training program specifically help achieve, according to the text? A. Eliminating the need for code reviews. B. Replacing automated security testing tools. C. Guaranteeing zero vulnerabilities in releases. D. Reducing security costs through motivation. Do you know the answer? Correct answer: D. Reducing security costs through motivation. Explanation. Option D is correct because the text states that training helps reduce the cost of security and that an effective training program will motivate the development team to produce more secure software with fewer problems. Option A is incorrect because security training enhances developer skills but does not eliminate the need for code reviews, which remain an important complementary practice within a comprehensive security development process. Option B is incorrect because training complements automated security testing tools rather than replacing them. The text advocates a holistic approach, blending people, process, and technology rather than substituting one for another. Option C is incorrect because no training program can guarantee zero vulnerabilities in software releases. The text states training reduces problems and costs, but does not claim it achieves perfection in eliminating all security flaws. Training is a big deal in the SDL, and the text lists specific benefits. The question asks which outcome an effective security training program achieves. The correct answer is D, reducing security costs through motivation. The text puts it this way: training helps reduce the cost of security, and an effective program motivates the development team to produce more secure software with fewer problems. When developers actually understand why security matters and how to write secure code, they catch issues earlier, write fewer flaws in the first place, and the whole process gets cheaper. Option A says training eliminates the need for code reviews. Training makes developers better, but code reviews are still a separate and necessary practice. Option B says training replaces automated testing tools. Training and tools complement each other. You don't swap one for the other. Option C says training guarantees zero vulnerabilities. No training program on Earth can promise that. The goal is reduction, not perfection. Here's a WGU D487 OA exam tip for you. When a question asks about SDL training benefits, the answer ties motivation to cost reduction. The text specifically links those two. Watch for eliminate or guarantee in wrong answers. Those are too absolute. Quick recall hook. Train devs = motivated. Devs = lower security costs. 43. The text describes the ideal software security professional as someone who can think like an adversary throughout the development process. This mindset is especially critical for threat modeling, which requires envisioning all possible attack vectors. What does the text specifically call this specialized capability? A. A standard quality assurance competency. B. A purely theoretical academic exercise. C. An art augmented by process and technology. D. An automated tool-driven skill set. Do you know the answer? Correct answer: C. An art augmented by process and technology. Explanation. Option C is correct because the text states that software security will still be considered an art for the foreseeable future, but this art can be augmented through process and technology and taught through mentorship. Option A is incorrect because the text explicitly distinguishes the adversarial thinking required for threat modeling from standard quality assurance competencies, noting that QA professionals typically think like customers, not hackers. Option B is incorrect because the text rejects the notion that software security expertise is purely theoretical. It states this art can be taught through proper mentorship by seasoned security architects with real-world experience. Option D is incorrect because the text emphasizes that while tools support the process, the core capability of thinking like an adversary requires human expertise and experience that cannot be reduced to an automated, tool-driven skill. The text describes the ideal software security professional as someone who can think like an adversary throughout the development process. That adversarial mindset is especially critical for threat modeling. So what does the text call this specialized capability? The correct answer is C, an art augmented by process and technology. The text uses the word art deliberately. Software security will still be considered an art for the foreseeable future. But it's not just raw talent with no structure. This art can be augmented by process and technology, and it can be taught through mentorship by seasoned architects and engineers. It's the combination that works. Human intuition supported by systematic approaches and tooling. Option A calls it a standard QA competency. The text specifically distinguishes adversarial thinking from the customer-focused mindset QA professionals typically have. Option B calls it a purely theoretical academic exercise. The text rejects that. It's practical and teachable through real-world mentorship. Option D calls it an automated tool-driven skill. The text says the opposite. The core capability is human expertise that tools can support but never replace. Here's a WGU D487 OA exam tip for you. When a question asks what the text calls software security expertise, the answer uses the word art. It's an art augmented by process and technology. The word art in the answer choices is your signal. Quick recall hook. Security expertise = art plus process plus technology. 44. The text emphasizes that no single point solution will provide a complete answer for software security. Instead, a holistic, defense-in-depth approach is required that blends three key components. Among people, process, and technology, which component does the text identify as deserving the heaviest emphasis? A. Technology and automated scanning tools. B. Documented processes and formal procedures. C. Compliance frameworks and audit requirements. D. People with security expertise and experience. Do you know the answer? Correct answer. D. People with security expertise and experience. Explanation. Option D is correct because the text explicitly states that a holistic, defense-in-depth approach requires a blend of people, process, and technology with a heavy emphasis on people as the most critical component. Option A is incorrect because while technology supports security efforts, the text specifically places the heaviest emphasis on people rather than automated scanning tools, noting that tools cannot replace human security expertise. Option B is incorrect because documented processes are an important component of the defense-in-depth blend, but the text specifically singles out people as deserving the heaviest emphasis among the three components. Option C is incorrect because compliance frameworks and audit requirements are external drivers for security programs, not one of the three key components the text identifies, which are specifically people, process, and technology. The text says no single point solution will give you complete software security. You need a holistic defense-in-depth approach that blends three components: people, process, and technology. But they're not weighted equally. The correct answer is D, people with security expertise and experience. The text explicitly says the heaviest emphasis goes to people. Tools are fast but blind to design flaws. Processes provide structure but don't think. People, experienced security professionals with adversarial mindsets, are the ones who tie it all together. They design the processes, interpret the tool results, and make judgment calls that no automation can replicate. Option A, technology and automated scanning tools, is one part of the blend but not the emphasized one. Option B, documented processes and procedures, is another piece, but the text doesn't place the heaviest weight there. Option C, compliance frameworks and audit requirements, aren't even one of the three components. The three are people, process, and technology. Compliance is an external driver, not an internal component. Here's a WGU D487 OA exam tip for you. When a question asks about the three-component blend and which gets the heaviest emphasis, the answer is people. People, process, technology. With people on top, quick recall hook. People first in the PPT blend. 45. Some practitioners argue that the adversarial thinking required for software security cannot be taught and is an innate talent. The text directly addresses this myth. What does the text assert about the teachability of software security skills through mentorship? A. The art can be taught through mentorship. B. Only self-taught individuals can succeed. C. Formal education alone is sufficient. D. Security thinking cannot be developed. What do you think is the answer? Correct answer. A. The art can be taught through mentorship. Explanation. Option A is correct because the text explicitly states that contrary to myths perpetrated by some practitioners, the art of software security can be taught through proper mentorship by seasoned architects and engineers. Option B is incorrect because the text contradicts the idea that only self-taught individuals can succeed by explicitly stating that mentorship from experienced professionals is an effective path to developing software security expertise. Option C is incorrect because the text emphasizes practical mentorship from seasoned architects and engineers who have real-world experience, not formal education alone, as the path to developing adversarial security thinking. Option D is incorrect because the text directly refutes this position, calling it a myth perpetrated by some practitioners, and affirms that software security thinking can indeed be developed through proper mentorship and guidance. Some practitioners in the industry claim that the adversarial thinking required for software security is an innate talent that can't be taught. The text calls this a myth. The correct answer is A. The art can be taught through mentorship. The text is direct. Contrary to myths perpetrated by some practitioners, software security expertise can absolutely be developed through proper mentorship by seasoned architects and engineers. You don't have to be born with a hacker's brain. You need experienced mentors who've been in the trenches and can show you how to think about attack vectors, design weaknesses, and exploitation paths. That hands-on guidance makes the difference. Option B says only self-taught individuals can succeed. The text contradicts this by specifically saying mentorship works. Option C says formal education alone is sufficient. The text puts the emphasis on practical mentorship from experienced practitioners, not classroom learning by itself. Option D says security thinking cannot be developed. This is the exact myth the text is debunking. Here's a WGU D487 OA exam tip for you. When a question asks whether software security skills are innate or teachable, the answer is teachable through mentorship. The text specifically refutes the born with it myth. Quick recall hook, not born mentored. Security skills are teachable. 46. Despite strong theoretical foundations, SDL practices have produced mixed results when applied in real enterprise environments. The text identifies several practical barriers to successful implementation. Which challenge does the text specifically cite as making it very difficult to apply SDL practices retroactively? A. Excessive developer enthusiasm for security. B. Overabundance of qualified security staff. C. Large legacy codebases in the industry. D. Too many available SDL frameworks to choose. Can you guess the answer? Correct answer. C. Large legacy codebases in the industry. Explanation. Option C is correct because the text specifically states that legacy code still forms a large codebase of the software industry, making it very difficult to go back in time and apply SDL practices retroactively. Option A is incorrect because the text describes the opposite problem. Developers and companies often work under tight deadlines, where security takes a back seat rather than generating excessive enthusiasm for security practices. Option B is incorrect because companies often lack qualified software security professionals internally and frequently must hire third-party contractors, indicating a shortage of qualified staff rather than an overabundance. Option D is incorrect because having too many frameworks to choose from is not cited as a barrier. The text identifies legacy code, outsourcing challenges, tight deadlines, and lack of management commitment as the primary obstacles. SDL practices have strong theoretical foundations, but real enterprise results have been mixed. The text identifies specific barriers, and this question asks about one in particular. What makes it very difficult to apply SDL practices retroactively? The correct answer is C, large legacy code bases in the industry. The text spells it out. Legacy code still forms a huge portion of the software industry's code base, and you can't go back in time to apply SDL practices to code that was written years or decades ago without security in mind. Retrofitting security into millions of lines of legacy code is a massive, expensive, and often impractical undertaking. Option A says excessive developer enthusiasm for security. That's the opposite of reality. Developers are usually pressed for time, and security takes a back seat. Option B says an overabundance of qualified security staff. Also the opposite. Most companies lack qualified security professionals and have to hire contractors. Option D says too many SDL frameworks to choose from. That's not a cited barrier. The real obstacles are legacy code, outsourcing deadlines, and lack of management commitment. Here's a WGU D487 OA exam tip for you. When a question asks about barriers to retroactive SDL application, legacy code bases is the answer. The phrase go back in time or retroactively paired with SDL points to legacy code. Quick recall hook. Can't SDL yesterday's code. Legacy is the barrier. 47. Software outsourcing and offshoring present unique difficulties for implementing SDL practices effectively. Combined with tight competitive deadlines and insufficient management commitment, these factors create an environment where security is often treated as an afterthought. What organizational behavior does this combination of pressures most commonly produce? A. Teams invest heavily in threat modeling. B. Security becomes a top development priority. C. Companies abandon software development entirely. D. Security is deprioritized under deadline pressure. What do you think is the answer? Correct answer, D. Security is deprioritized under deadline pressure. Explanation. Option D is correct, because the text states that developers work under tight deadlines to release products before competition, causing software security to typically take a back seat, combined with a lack of management commitment. Option A is incorrect because the combined pressures of outsourcing, deadlines, and insufficient management commitment lead to reduced security investment, not heavy investment in time-consuming activities like threat modeling. Option B is incorrect because the text describes the opposite reality. Competitive pressures and management shortcomings cause security to be deprioritized rather than elevated to a top development priority within organizations. Option C is incorrect because companies do not abandon software development due to security challenges. Instead, they continue developing software while unfortunately treating security as an afterthought under competitive pressure. Outsourcing, offshoring, tight deadlines, and weak management commitment. Put those together and what do you get? The correct answer is D. Security is deprioritized under deadline pressure. This is the reality the text describes. When teams are racing to beat competitors to market, security gets shoved to the back of the line. Management isn't pushing for it, the budget is tight, and some of the work is happening overseas where SDL enforcement is harder. The result is predictable. Security becomes an afterthought. Option A says teams invest heavily in threat modeling. That's the opposite. Threat modeling takes time, and these pressured teams don't have it. Option B says security becomes a top priority. The text describes the exact opposite happening under these conditions. Option C says companies abandon software development entirely. Nobody stops building software because of security challenges. They just build it insecurely. Here's a WGU D487 OA exam tip for you. When a question combines outsourcing, deadlines, and poor management commitment, the answer is security deprioritization. That triple combination always points the same direction. Quick recall hook, deadlines plus outsourcing plus weak management equals security last. 48. The text states that software security requires a focused effort and is not a natural outcome of conventional development processes, even from teams with good quality practices. Which important conclusion should organizations draw from this statement about the relationship between quality programs and security outcomes? A. Security requires deliberate, dedicated effort. B. Conventional development naturally yields security. C. Good quality practices guarantee secure software. D. Quality programs automatically produce security. Can you guess the answer? Correct answer, A. Security requires deliberate, dedicated effort. Explanation. Option A is correct, because the text explicitly states that software security requires a focused effort to be successful and is not a natural outcome of conventional software development processes, regardless of quality practices. Option B is incorrect because the text explicitly contradicts this claim, stating that software security is not a natural outcome of conventional development processes, even when those processes are well established and mature. Option C is incorrect because the text states that even development groups with good traditional quality practices do not automatically produce secure software, requiring separate focused security efforts beyond quality assurance alone. Option D is incorrect because the text directly states that security is not an automatic outcome of quality programs. Organizations with strong quality practices can still produce insecure software without dedicated security efforts. The text makes a statement that a lot of organizations need to hear. Software security requires a focused effort and is not a natural outcome of conventional development processes. Even teams with good quality practices don't automatically produce secure software. The correct answer is A. Security requires deliberate, dedicated effort. This is the takeaway. You can have the best QA program in the world, mature development processes, and excellent code quality, and still ship insecure software. Security doesn't happen as a side effect of doing other things well. It has to be intentionally built into the process, with its own dedicated activities, resources, and attention. Option B says conventional development naturally yields security. The text explicitly says the opposite. Option C says good quality practices guarantee secure software. They don't. Quality and security are complementary, but separate. As we've covered in earlier questions, Option D says quality programs automatically produce security. Again, the text rejects this directly. Here's a WGU D487 OA exam tip for you. When a question asks about the relationship between quality programs and security outcomes, the answer is that security needs its own deliberate effort. The phrase, not a natural outcome, is your trigger. Quick recall hook. Security doesn't happen by accident. It takes dedicated effort. 49. The text argues that security improvements to development processes are possible, practical, and essential regardless of the development methodology being used. Which range of development approaches does the text specifically state should incorporate security practices? A. only Agile and Scrum methodologies? B. Exclusively traditional waterfall approaches? C. Waterfall, Agile and blended methodologies? D. Only methodologies approved by Microsoft? Correct. Do you know the answer? Correct answer, C. Waterfall, Agile and blended methodologies. Explanation: option C is correct because the text explicitly states that developers will be scrutinized whether they use traditional waterfall, Scrum and Agile, or a blended development methodology for their security practices. Option A is incorrect because the text does not limit security practices to Agile and Scrum methodologies alone. It explicitly includes traditional waterfall and blended approaches as environments that should incorporate security development practices. Option B is incorrect because restricting security practices exclusively to waterfall approaches contradicts the text, which specifically names Agile, Scrum, and blended methodologies as equally requiring security integration throughout development. Option D is incorrect because the text does not restrict SDL applicability to Microsoft-approved methodologies. It presents security development practices as universally applicable across all development approaches used by any organization. The text argues that security improvements to development processes are possible, practical, and necessary no matter what development methodology you're using. The correct answer is C. Waterfall, Agile, and blended methodologies. The text names all three explicitly. Whether your team uses traditional waterfall, Scrum and Agile, or some blended combination, security practices need to be part of the picture. Developers will be scrutinized on security regardless of their methodology choice. There's no methodology that gets a free pass. Option A says only Agile and Scrum. The text specifically includes waterfall too. Option B says exclusively waterfall. The text names Agile and blended approaches alongside it. Option D says only Microsoft-approved methodologies. The text doesn't limit SDL to any vendor's preferred approach. Security development practices are universally applicable. Here's a WGU D487 OA exam tip for you. When a question asks which methodologies need security practices, the answer includes all of them. Waterfall, Agile and blended. If an option says only one type, it's wrong. Quick recall hook. All methodologies need security, waterfall, Agile, blended. 50. The text concludes that the book addresses perhaps the most critical challenge in information and cybersecurity over the coming years. Its model is designed for executives, managers, and practitioners alike. Which fundamental belief drives the author's argument that their presented security best practices model can succeed across different organizational roles? A. Only executives can implement security changes. B. Security improvements are possible and practical. C. Practitioners need no management support. D. Managers should handle all coding decisions. Do you know the answer? Correct answer, B. Security improvements are possible and practical. Explanation: option B is correct because the authors explicitly state their belief that security improvements to development processes are possible, practical, and essential, providing the foundational conviction behind their cross-organizational best practices model. Option A is incorrect because the text addresses executives, managers, and practitioners together, indicating that successful security implementation requires engagement across all organizational roles rather than executive action alone. Option C is incorrect because the text identifies lack of management commitment as a barrier to SDL success, demonstrating that practitioners absolutely require management support to effectively implement security development practices. Option D is incorrect because the text distributes security responsibility across multiple roles, including executives, managers, and practitioners. Coding decisions should involve security-trained developers rather than being handled solely by managers. We've reached the final question. and it's about the fundamental belief that drives everything in the book. The authors designed their model for executives, managers, and practitioners. What conviction sits behind the argument that their best practices model can work across all those roles? The correct answer is B. Security improvements are possible and practical. The authors explicitly state their belief that security improvements to development processes are possible, practical, and necessary. That conviction is the foundation of the entire book. If they didn't believe improvements were achievable in the real world, there'd be no point in writing the book. Notice the word practical. This isn't just theoretical optimism. They believe it can actually be done within the constraints of real organisations. Option A says only executives can implement security. The text addresses all three roles together. Security is everyone's job. Option C says practitioners need no management support. The text identifies lack of management commitment as a major barrier, so practitioners absolutely need management backing. Option D says managers should handle all coding decisions. The text distributes responsibility across all roles, not just one. Here's a WGU D487 OA exam tip for you. When a question asks about the foundational belief of the text's model, the answer is that security improvements are possible and practical. This is the book's core thesis. The words possible and practical together are your key. Quick recall hook. The book's core belief =, security improvements are possible and practical. You have reached the end of our first question set. For the free complete exam preparation, visit our website, link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.